Implementation of blockchain protocols in 2024, a comprehensive overview. Introduction. In 2024, the blockchain landscape is expected to evolve significantly, primarily driven by a strategic investment of $5 million aimed at enhancing interoperability among diverse blockchain networks. This initiative outlines a structured approach divided into 4 critical stages: research and development, integration, testing, and deployment. Each stage is designed to address existing interoperability challenges and promote seamless communication across blockchain ecosystems. Stage 1: Research and Development. Objectives. The first stage focuses on conducting comprehensive research to identify and analyze the current interoperability challenges faced by various blockchain networks. This involves gathering data from multiple ecosystems to understand common pitfalls and potential solutions. Key activities. Data collection. Researchers will gather insights from existing blockchain projects. Identifying specific interoperability issues. Troubleshooting existing protocols, analyzing the limitations of current protocols and technologies to uncover areas for improvement. Innovative solutions, exploring cutting-edge technologies and methodologies that could enhance interoperability, such as cross-chain communication techniques and decentralized oracles. Expected outcomes. The research phase aims to produce a detailed report outlining the key interoperability challenges and a set of recommendations for potential solutions that can be developed in the subsequent stages. Stage 2: Integration. Objectives. The second stage aims to create protocols that facilitate seamless integration between different blockchain platforms. This phase emphasizes collaboration with existing projects to ensure compatibility. Key activities. Collaborative development, engaging with stakeholders from various blockchain networks to co-develop integration protocols. Protocol design, designing new interoperability protocols that can be easily adopted by diverse blockchain ecosystems. Standard setting, working towards establishing common standards that would govern how different blockchains interact. Expected outcomes. By the end of the integration phase, a set of new protocols and standards will be established, allowing for improved communication channels between disparate blockchain networks. Stage 3: Testing. Objectives. Testing is a critical phase that validates the functionality, security, and robustness of the developed protocols before full-scale deployment. Key activities. Controlled environment testing, conducting rigorous tests in controlled environments to assess the protocols under various conditions. Vulnerability assessment, identifying and addressing potential vulnerabilities to ensure the protocols can withstand real-world attacks and stress scenarios. Performance evaluation, measuring the protocol's efficiency in handling transactions and data exchanges across networks. Expected outcomes. Successful completion of the testing phase will yield verified protocols that meet predefined security and performance benchmarks ready for deployment. Stage 4: Deployment. Objectives. The deployment stage focuses on the full-scale implementation of the newly developed interoperability protocols across selected blockchain networks. Key activities. Implementation, rolling out the protocols across participating blockchain networks. Ensuring all systems are updated and compatible. Monitoring, establishing real-time performance monitoring systems to assess how well the new protocols are functioning. User adoption strategies, implementing strategies to encourage user adoption and engagement with the new systems, including education and outreach programs. Expected outcomes. By the end of this stage, the interoperability protocols will be operational with a user base that has been educated on their benefits and functionalities. Investment strategy. The $5 million investment will be strategically allocated across the 4 stages to ensure effective resource utilization and long-term sustainability of the interoperability solutions. The allocation will emphasize 1. Research and development. Approximately 30% of the budget will be dedicated to research initiatives aimed at uncovering existing challenges and potential solutions. 2. Integration. Another 30% will focus on collaborative development with existing blockchain projects, ensuring the protocols are widely compatible. 3. Testing. Roughly 25% will be allocated to rigorous testing procedures, emphasizing security and performance validation. For deployment, the remaining 15% will support the deployment phase, including user education and monitoring systems. Timeline of events. The implementation timeline is outlined as follows. Q1 2024, initiate the research and development phase. Q2 2024, transition into the integration phase, engaging with blockchain stakeholders. Q3 2024, conduct extensive testing of the developed protocols. Q4 2024, full-scale deployment of interoperability protocols across selected networks. Conclusion. The structured approach outlined in this initiative aims not only to enhance interoperability among blockchain networks but also to serve as a blueprint for future innovations in blockchain technology. The strategic investment reflects a commitment to overcoming current limitations in blockchain communication, ultimately fostering a more interconnected and efficient blockchain ecosystem. As the initiative progresses, it is anticipated that the advancements made will pave the way for a new era of blockchain applications and solutions that can seamlessly operate across different platforms. The content reveals several counterintuitive insights regarding the implementation of blockchain protocols in 2024, particularly focusing on interoperability and investment strategies. 1. Investment allocation versus expected outcomes. It may be assumed that a significant investment such as the proposed $5 million would guarantee rapid advancements in interoperability. However, the structured approach, which emphasizes thorough research and development followed by integration testing and deployment, indicates that real progress may take longer than anticipated. The counterintuitive aspect here is that substantial upfront investment does not equate to immediate results, rather, it necessitates a methodical approach that could delay the visible impact of the investment. 2. Focus on collaboration. The second stage emphasizes the importance of collaboration with existing blockchain projects and stakeholders. This is counterintuitive because one might expect that a new initiative would seek to develop its own protocols independently. Instead, the success of the interoperability protocols heavily relies on integrating with existing systems, which can often lead to challenges in aligning different stakeholders' interests and technological frameworks. 3. Rigorous testing phase. Many might assume that once protocols are developed, they can be quickly deployed across networks. The emphasis on a rigorous testing phase challenges this notion. It suggests that the industry is moving towards a more cautious and responsible approach, acknowledging that rushing to deployment could lead to vulnerabilities and failures that undermine the entire initiative. 4. User adoption as a critical factor. The deployment phase highlights the necessity of user adoption and real-time performance assessments. This is counterintuitive because it implies that even well-designed protocols can fail if users do not embrace them, suggesting that the success of blockchain innovations is not solely dependent on technological advancements but also on market acceptance and user engagement. 5. Future adaptability. The investment strategy mentions that the protocols must be adaptable to future technological advancements and market changes. This indicates a shift in mindset, rather than creating a one-size-fits-all solution. There is an acknowledgement that the blockchain landscape is dynamic. This counters the traditional notion that a successful protocol should be rigidly defined and static. 6. Common misconceptions about interoperability. There is a prevalent belief that interoperability can be achieved simply through technical solutions. However, the need for extensive research into existing challenges suggests that many technical solutions may overlook underlying issues related to governance, regulatory compliance, and user behavior. This implies that achieving interoperability is as much about understanding the ecosystem as it is about developing technology. 7. Sustainability over immediate gains. The content emphasizes long-term sustainability of interoperability solutions over quick wins. This is counterintuitive in an industry that often prioritizes rapid innovation and immediate market capture. The focus on creating robust and adaptable protocols suggests a strategic pivot towards valuing enduring solutions that can evolve with the market rather than those that may provide short-term success. In summary, the insights provided reveal a complex landscape where assumptions about investment, collaboration, user behavior, and the nature of technological development in blockchain interoperability may not align with the realities of implementation. The report on the implementation of blockchain protocols in 2024 highlights 4 critical stages of development. Alongside a $5 million investment strategy aimed at enhancing interoperability across various blockchain networks. While the summary captures the essence of the initiative, several significant aspects are easily overlooked which can have profound implications for the future of blockchain technology. 1. Emphasis on research and development. Significance. The first stage of the initiative focuses heavily on research and development (R&D) to identify existing interoperability challenges. This is often underestimated because many stakeholders may assume that interoperability is a straightforward technical issue. However, the complexities of diverse blockchain environments, each with unique protocols, governance structures, and use cases, make R&D crucial for understanding the underlying problems. A deeper investigation into these challenges may reveal unforeseen obstacles that could derail the integration process. The report suggests that gathering data from various ecosystems is vital. This phase is not merely about identifying technical solutions but also about understanding user needs and behaviors. By prioritizing R&D, the initiative sets the stage for more user-centric solutions which are critical for real-world adoption. 2. Collaborative integration efforts. Significance. The second stage emphasizes integration, which necessitates collaboration with existing blockchain projects and stakeholders. This collaboration is significant because it acknowledges the ecosystem's diversity and the need for consensus among various players. Many reports may gloss over the importance of collaboration, focusing instead on technical solutions alone. The reality is that without the buy-in and cooperation of existing stakeholders, even the most technically sound interoperability protocols can fail. This stage's success relies on building trust and shared goals among different blockchain communities. Such collaboration can also foster innovation by combining diverse ideas and approaches, leading to more robust solutions. 3. Rigorous testing phase. Significance. The testing phase is critical yet frequently underappreciated. The report notes that rigorous testing in controlled environments is essential for validating both functionality and security. Often projects may rush to deployment believing that they can resolve issues post-launch. However, this approach can lead to catastrophic failures, especially in blockchain applications where security and reliability are paramount. Vulnerabilities discovered during testing can have severe implications, including financial losses and reputational damage. The emphasis on a thorough testing phase is significant as it highlights the initiative's commitment to quality and security, which are essential for gaining user trust and achieving long-term adoption. 4. Strategic deployment and user adoption. Significance. The deployment phase's success hinges on user adoption and real-time performance assessments. While many reports may focus on the technological aspects of deployment, they often overlook the necessity of understanding and facilitating user adoption. User education incentives and addressing potential resistance to change are critical factors that determine whether new protocols will be embraced. The report's acknowledgement of this aspect is significant as it positions user engagement as a crucial element of the deployment strategy. Without a strong focus on user needs and experiences, the initiative risks launching protocols that fail to meet user expectations and as a result do not achieve the desired interoperability. 5. Long-term sustainability and market adaptability. Significance. The investment strategy allocates resources across the 4 stages, aiming for long-term sustainability and adaptability to future technological advancements. This foresight is often overlooked in discussions that focus solely on immediate technological solutions or short-term gains. By prioritizing sustainability, the initiative recognizes that blockchain technology is not static, it evolves rapidly with changing market dynamics. This perspective is significant because it helps ensure that the interoperability solutions developed today can accommodate future innovations and challenges, thereby extending their usefulness and relevance. 6. Economic implications and use cases. Significance. While the report mentions the need for interoperability, it also touches on the varying focuses of different sources regarding specific use cases. The economic implications of enhanced interoperability are profound, affecting sectors like finance, supply chain management, and beyond. Many discussions may overlook the tangible economic benefits that can arise from seamless communication between blockchains, such as reduced transaction costs, improved efficiency, and the potential for new business models. Understanding these economic implications is crucial for stakeholders, as it provides a compelling argument for investment and participation in interoperability initiatives. The successful implementation of these protocols could lead to a more interconnected and efficient blockchain ecosystem, driving innovation and economic growth. 7. The role of governance in interoperability. Significance. Governance structures within different blockchain networks can significantly affect interoperability efforts. Many reports might not delve into the complexities of governance, which can impede collaboration and integration. Different networks often have varying governance models, which can lead to conflicts or misalignments in objectives. The significance lies in recognizing that effective governance mechanisms must be established to facilitate cooperation among diverse blockchain ecosystems. This aspect is crucial for ensuring that all stakeholders have a voice in the development process and that the resulting protocols reflect a shared vision for interoperability. Conclusion. The initiative's comprehensive approach to enhancing blockchain interoperability through research, integration, testing, deployment, and sustainability is commendable. However, the critical aspects highlighted above, particularly the importance of collaboration, user adoption, thorough testing, and governance, are often overlooked in discussions surrounding blockchain technology. Recognizing and addressing these elements will be key to the successful implementation of interoperability protocols and the broader adoption of blockchain solutions in the coming years. The implementation of blockchain protocols in 2024, supported by a strategic $5 million investment, is centered on enhancing interoperability across various blockchain networks. Here are 4 critical points for in-depth analysis and discussion. 1. Research and development phase. The first stage emphasizes the importance of thorough research to identify and analyze existing interoperability challenges among blockchain networks. This stage is crucial as it lays the foundation for subsequent stages. An in-depth understanding of the current gaps in blockchain communication can lead to innovative solutions tailored to specific ecosystem needs. The focus on gathering data from various blockchain ecosystems and analyzing common pitfalls is likely to yield insights that can drive the development of protocols that enhance communication and data exchange. This phase also involves stakeholder engagement, ensuring that the needs and preferences of various blockchain participants are considered, fostering a sense of collaboration. 2. Integration of protocols. The integration stage is where the theoretical findings from the research phase are translated into practical, operational protocols. This requires collaboration with existing blockchain projects and stakeholders, ensuring compatibility across different systems. The development of these protocols is essential for enabling seamless communication between disparate blockchain networks, which is a significant hurdle in the current blockchain landscape. A critical discussion point here revolves around the technical challenges of integrating protocols across different blockchain architectures, e.g., permission versus permissionless varying consensus mechanisms, and the role of standards in facilitating this integration. The effectiveness of the protocols developed will largely depend on their adaptability to diverse blockchain environments. 3. Testing for security and functionality. The testing phase is pivotal for validating the newly developed protocols. Rigorous testing in controlled environments is necessary to identify vulnerabilities and ensure that the protocols can support real-world transactions without compromising security. This stage raises important questions regarding the methodologies used for testing, such as stress testing, security audits, and user acceptance testing. Moreover, an in-depth discussion could explore the implications of security breaches in interoperability solutions, the potential impact on user trust, and the measures that can be implemented to enhance security frameworks. As the blockchain ecosystem becomes more interconnected, the importance of robust security measures cannot be overstated. 4. Deployment and adoption. The final stage focuses on the full-scale deployment of the interoperability protocols. Success in this phase is contingent upon user adoption and performance assessments in real-time scenarios. Understanding the factors that drive or hinder user adoption is key to the long-term sustainability of these protocols. This includes examining the economic incentives for users to switch to interoperable protocols, the role of education in fostering user understanding, and the potential for regulatory frameworks to either facilitate or complicate adoption. Additionally, the discussion should address the implications of successful deployment on the broader blockchain ecosystem, including potential use cases in sectors like finance and supply chain management. Conclusion. The structured approach to implementing blockchain protocols in 2024 highlights the significance of each stage in enhancing interoperability. The $5 million investment reflects a commitment to addressing current limitations in blockchain communication. A comprehensive discussion around these 4 critical points will not only illuminate the complexities of achieving interoperability but also set the stage for future innovations in the blockchain space. Famous historical cases similar to blockchain protocol interoperability. 1. The development of the Internet Protocol Suite (TCP/IP). The creation and adoption of the Transmission Control Protocol (TCP) and Internet Protocol (IP) in the 1970s and 1980s serve as a pivotal example of achieving interoperability among diverse systems. Originally developed for ARPANET, TCP/IP became the foundational protocol for the modern Internet, enabling different networks to communicate effectively regardless of their underlying architectures. This transition involved extensive research and development, integration of various network types, rigorous testing for reliability and security, and ultimately widespread deployment that transformed global communication. 2. The standardization of the ISO, International Organization for Standardization. In the late 20th century, the ISO played a crucial role in establishing standards for various industries, similar to the goal of achieving interoperability in blockchain networks. The ISO 9000 series for quality management and the ISO 27000 series for information security management are examples where diverse organizations adopted common standards to ensure compatibility, efficiency, and quality assurance across different systems and products. This process involved stages akin to those in blockchain protocol development, researching existing practices, integrating standards into organizational practices, testing compliance, and deploying the standards across industries. 3. The evolution of electrical standards in the late 19th century. The transition from numerous competing electrical standards to a unified system in the late 1800s demonstrates the necessity of interoperability for technological advancement. Early electrical systems were often incompatible, leading to confusion and inefficiency. The eventual adoption of standards such as the 120V AC system in the United States allowed for the widespread use of electrical appliances and systems, facilitating communication and compatibility among manufacturers and users alike. This historical case involved phases of research into existing technologies, integration of standards across different electrical frameworks, extensive testing for safety and reliability, and eventual deployment that paved the way for modern electrification. These historical cases highlight the critical importance of establishing interoperability within various technological contexts, serving as a guide for the current challenges faced in blockchain protocol development. Each case emphasizes the necessity of thorough research, collaborative integration, rigorous testing, and strategic deployment to achieve successful interoperability. In 2024, the implementation of blockchain protocols will evolve significantly, driven by a focused $5 million investment aimed at enhancing interoperability across various blockchain networks. This initiative will unfold in 4 critical stages: research and development, integration, testing, and deployment. Future outlook: predictions for blockchain protocols in 2024. 1. Enhanced interoperability. The primary goal of the upcoming blockchain protocols will be to solve existing interoperability challenges. As more blockchain networks emerge, the need for them to communicate effectively becomes increasingly crucial. Predictions indicate that by the end of 2024 we will see a marked improvement in cross-chain capabilities, enabling seamless transactions and data sharing across multiple platforms. This will facilitate new use cases in finance, supply chain, and identity management, transforming how businesses operate. 2. Stage 1, Research and Development, Q1 2024. The research phase will focus on identifying specific interoperability gaps between blockchain networks. Expect an influx of academic and industry collaborations that will lead to innovative solutions. Data analytics and AI-driven insights will play a vital role in understanding common pitfalls, allowing developers to create protocols that not only address current challenges but also anticipate future needs. Prediction: by March 2024 we will see the release of comprehensive reports outlining key interoperability challenges along with initial proposals for potential solutions. 3. Stage 2, Integration, Q2 2024. In the integration phase, developers will work closely with existing blockchain projects to create new protocols. This process will likely involve the establishment of consortiums or partnerships between various stakeholders, including developers, businesses, and regulatory bodies. The focus will be on ensuring that these new protocols are compatible with a wide array of systems. Prediction: by June 2024. Several pilot projects demonstrating successful integration between different blockchain platforms will be launched, showcasing real-world applications of the new protocols. 4. Stage 3, Testing, Q3 2024. The testing phase will be critical for validating the new protocols. Rigorous testing environments will be established to identify vulnerabilities and ensure that the protocols can handle real-world workloads. Expect a significant emphasis on security, performance, and scalability during this stage. Prediction: by September 2024 we will witness the completion of extensive testing phases, with public audits and security assessments being a standard practice, thus boosting community trust in the new protocols. 5. Stage 4, Deployment, Q4 2024. The final stage involves the full-scale deployment of the interoperability protocols across selected blockchain networks. User adoption will be a key factor in determining the success of this phase. Continuous monitoring and real-time performance assessments will be essential to ensure the protocols meet their intended interoperability goals. Prediction: by December 2024. We will see widespread adoption of the new protocols across major blockchain networks, significantly improving the landscape of decentralized finance, DeFi, and other blockchain-based applications. Investment strategy. The $5 million investment will be allocated strategically across the 4 stages, ensuring that resources are used efficiently. This investment reflects a commitment to building robust, adaptable protocols that can evolve with technological advancements and market demands. Future prediction: This investment strategy will not only address immediate interoperability challenges but also set a foundation for ongoing research and development in blockchain technology, encouraging further investment and innovation in the sector. Summary of key points. Interoperability needs. As blockchain networks proliferate, enhancing interoperability will be paramount. Collaborative approach. Strategic partnerships and collaborations will be essential for the successful development and integration of new protocols. Real-world applications, pilot programs and case studies will demonstrate the effectiveness of new protocols. Driving user adoption. Long-term vision. The initiative will lay the groundwork for future innovations in blockchain technology, promoting a more interconnected ecosystem. In conclusion, the strategic $5 million investment in blockchain interoperability protocols will catalyze significant advancements in 2024. By focusing on research, integration, testing, and deployment, the initiative aims to create a more seamless and interoperable blockchain ecosystem, ultimately transforming how various sectors leverage blockchain technology.